Okay, so let's talk about how we're going to get our act together and get this job done. Before we get into the particulars of what it is we have to do now, let's remind ourselves that things actually have to happen at 3 different levels. That's really bad. I can't see it myself up there. You got good eyesight, Ed. Things have to happen at the executive level, they have to happen at the legislative level, and they have to happen in the scientific community and the public. And we need to be involved at all of these levels, but we have to be involved in different ways. Of course, ultimately, the President and his officers, the OMB, the OSTP, the Secretary of Energy, the NSF Director, have to be convinced that this is the right thing to do. Likewise, the Congress, and particularly the Appropriation and Authorization Committees for the DOE and the NSF, have to be convinced that this is the right thing to do. And you will have to be involved with the congressman from your district, so when it comes time to vote, he says, yeah. And of course, the scientific community and the public will be also a very big challenge. We have to convince our colleagues that this particular part of basic science is something that's so important that they should support us, even though it costs an awful lot of money. And we have to convince the general public that we're not wasting their funds, that this is something that's important for their culture and their understanding of where they fit into the universe. And of course, as I said, we all have to be involved in initiating and nurturing these activities at all levels in different ways. And perhaps most importantly, it has to be a coherent effort worldwide. We used to think that we had to have a worldwide effort, and we still do think, in order to have the necessary financial resources. We used to think that, and we still do think, that we need a worldwide effort to have the intellectual resources we need to do the job. But we also are going to have a worldwide effort, mark my words, to have the political power that we need to get this thing accepted. We all around the world, our community has to say, go for it. Okay, so what do we actually have to do? Well, of course, the list is as long as your arm, but here is a way of decomposing some of the important steps that have to be taken into account. First of all, and this is in the framework, of course, of creating a truly international organization to carry out and operate this project and do the physics. We have to devise an acceptable and accountable mechanism for U.S. participation in a completely internationalized project. We have to make the linear collider case with the administration, Congress, and the other communities and the public. Preferably in an international context, we have to devise, set up, and carry out, as suggested by the long-range panel by the end of 2003, a decision mechanism for choice of technology on which to focus our efforts. Now you might say, well, what's that mean? I understand that we've got to get this done, but how can you imagine doing it? Well, there are a number of ways that you could imagine doing it, and let me just illustrate it by one diagram here, which was taken from the idea that was behind the technology selection of the SSC. That was so long ago, you've probably all forgotten about it, but there are actually 3 competing technologies for the SSC that had to be sorted out early in the game. So the method that was used and the method that worked was to form a technology recommendation panel. In our case, we would hope that it could be international in composition. And that technology recommendation panel was composed of distinguished experimental particle physicists, plus 1 or 2 people who were expert in magnet technology and could answer detailed questions. They took evidence from, of course, the proponents of these various magnet technologies, and they took evidence from they had hearings, and they also read everything that was written about these 3 technologies, and then they made a selection, a recommendation, and it was such a distinguished panel that that recommendation stuck. I would suggest that we might emulate that in this particular case with some variation. Have the panel, actually in the case of the SSC, it was international, but that was because we needed to have a wide background, even though it was a national decision. So we would have, I'm saying that we might want to use the same paradigm for the panel itself. We now have an ICFA activity, the low panel, that is going to be doing a comparison on a strictly technical level. And of course, we will have the proponents of each of the technologies that are being put forward. And in this particular case, it seems important also to take input from the community. It was not done in the SSC case because of a different history and different reasons, but now it would seem appropriate to do so. And then this panel, if they did their work well, would be able to make a recommendation to whom it may concern, and it could be used as a basis for proceeding. This is not guaranteed to work. If it turns out that these technologies are all a wash, then we'll have to go another step and take some other means for making the decision, but this is a place to start. Okay, we need also to support and coordinate the R&D required for the American share of the Linear Collider Accelerator Facility. We have to support and coordinate the necessary detector R&D and the U.S. detector design activities. We need to draft a proposal for an international linear collider facility to be sited in the U.S., including a technology choice. And somehow, of course, we have to arrange eventually for the support and oversight of the U.S. share of a linear collider creation and operation. Okay, of course, there's always more than one way to skin a cat, and it's going to be up to us in the next months, weeks and months, to try and figure out what's the most appropriate thing for our particular condition. So, this DOE NSF long-range panel has called for a steering group, we might call it the U.S. steering group, to coordinate at least part of these activities. The expectation being that carrying out those 7 different jobs, however you want to parse them, will be done by different entities, and therefore it's necessary to coordinate the activities somehow so that we get to a common result in the most efficient possible way. Now maybe this steering group could actually do some of these jobs itself. For example, it could do the drafting the plans and coming up with the devising of a technology selection process. And they could obviously play a very strong role in coming up with that proposal from our community to our government, asking them to support the building of a linear collider in the US of A. The technical parts of it, the R&D and so forth, this steering group might play a role in coordinating it, but they would hardly be appropriate for actually carrying it out. We'll come back and talk about that in a minute. This business of the oversight and support of the ultimate construction operation, of course, will be governed by whatever relationships are devised when we decide how we're going to actually join the international effort. Now, in order to do this, in order to set up this steering group that's been recommended by our long-range panel, the NSF and the DOE could agree to manage the steering group directly, or perhaps less burdensome, to assign the task to a subcontractor of some kind. Now, the subcontractor could be one of the labs, but it doesn't take a great deal of imagination to see that there might be at least an apparent conflict of interest. The subcontractor could be some broadly representative consortium already involved in high-energy physics, such as URA, with a separate board of overseers for this function in order to avoid any of the apparent perceived conflict of interest. And, of course, this board of overseers, with agency guidance, appoint the steering group to carry out those functions that we just mentioned. The agency oversight of this subcontractor could then be a joint task force of the DOE and the NSF, as is the case in the LHC international participation. Okay, there were technical tasks on that list of items. Detector and facility R&D, accelerator R&D. And here's an opportunity for university collaboration, such as the ones now involved in the muon-based neutrino factory R&D, with perhaps the leadership and management could be shared among university groups on a rotating basis or some other way of doing it. I'll come back and say just a little bit more about that in a moment, just to go on and finish the thought that these collaborations might then form core groups that would participate in realizing the linear collider as subcontractors to the international entity. And in the case of the NSF, the associated university groups might be the core of a MRE proposal, which would be required for the NSF to become strongly coupled to this project. Let's take a moment to just look and see how this muon collaboration works to give you some idea of what we're talking about. Let me start from the microscopic side of the question. In the case of the NSF, there is a contractor, a university that's appointed as a contractor to be the project manager, the bookkeeper, the reporter, and the whip cracker, if you will. And then the R&D performers are the university groups. In this current time in the muon collaboration, there happen to be 10 university subgroups which work through subcontracts to the university contractor, and this is all done by mutual agreement. We all got together, we decided what we wanted to do, we described it in great detail, put it into our proposal to the NSF, and then wrote it up in the terms of subcontracts, and it works very smoothly. It's a little more complicated in the case of the DOE. Here the MC organization that reports to the DOE looks more like a detector collaboration, and has a spokesperson and a project manager and some co-spokespersons, and then it has an executive board and a technical board, and various university groups and individuals report through this mechanism and eventually to the DOE. And the executive and the technical boards, of course, are drawn from this group of 150 R&D performers, and the project manager is appointed by the spokesperson with advice and consent from the DOE. However, when you look and see how these things are integrated together, it looks quite a bit more complicated. And the reason I'm showing you this is not to particularly advertise or recommend this way of doing things, but to point out that we are capable of rather complex social organizations, and this thing, and it actually works. I mean, there are a lot of functions that have to be carried out here. There's all this unifying of what has to be done, and then making sure that the labs and the DOE are happy with how the funds are being used and how the work is going on. You should realize that the muon collaboration uses the facilities at the laboratories, and that has to be done with the cognizance of the laboratories, and the laboratories actually put in manpower, materials, and supplies. So it's quite a complicated business, but it does work. And perhaps tomorrow when we're having our town meeting, we could go through this in a little more detail to see how it actually works. I don't want to take your time to do that now. Currently, the accelerator R&D, the situation that we're facing here is a little bit different. In the case of the muon collaboration, it's all accelerator R&D. There's very little affinity detector R&D at all, and none of the big labs has picked up the muon collaboration neutrino source or muon collider as its favorite project. So this is really a grassroots operation from the start. At the moment, that's not the way it is with the linear collider. There are several laboratories that have made this their goal for the future, and so we will have to make our organization match to that a very important condition. At the moment, accelerator R&D is partially coordinated through the principal lab performers, so that there is a place for interested university participants to get involved. Perhaps once the technology choice is made, if we're ever able to do that, it will be a more active coordination might be appropriate. Okay, what about internationalization? We haven't talked about that explicitly. Let's talk about it explicitly for just a couple of minutes here. And again, there are many views on how one might carry this out. I'm only going to give you one possible view. And in trying to come up with this view, which is not unique to me, this is the result of many, many conversations across the face of the globe. Certain assumptions were put down as being the governing assumptions. Assumption number one, the major collaborating countries will each take significant share of the ownership of the linear collider and will have significant prerogatives in determining the technical design of the facility and the policies delimiting its operation. Second assumption, existing institutional structures will be the primary technical and manpower resources for design, construction, and operation of the new facility. This is an extremely important condition. I don't have time to discuss it in full. Perhaps we could do that later. Two of the things that it does for you, which are very important, is this kind of a structure maintains the needed physics diversity in the worldwide program. It helps to carry the particle physics culture regionally, which is really important in our relations with the public and with our government institutions. It's this assumption number 3 is that the determination and realization of the detector will be handled in a manner similar to previous ventures in international realization of accelerator facilities. The view that I'm going to present to you here, not the only view by any way, shape, or means, is that we could meet the boundary conditions set by these assumptions with a corporate structure. Consonant with the assumptions, one could constitute a limited liability corporation. Major countries are their agents being the shareholders with votes proportional to share in supporting the facility realization and operation. It should have a limited life, say 20 years, which is renewable by mutual consent. The shareholders elect a board of directors with technical, scientific, and policy oversight of the Linear Collider Corporation. Each major shareholder will be represented by a director. The directors are distinguished scientists or administrators familiar with the conduct of elementary particle physics or of science policy. Let me just show a diagram of how this might look to make it a little bit more comprehensible. It's a standard corporate type of structure in which the shareholders are the countries, a few countries. After all, we want to make sure that this thing doesn't become total chaos, and so it might be that the countries who are all going to contribute, say, at least 10% or even a little bit more, could be directly represented in the shareholders meeting, and then there may be consortia of countries that want to get together to collectively put in something like 10%. And these are the examples of the countries that come to mind immediately. And then the shareholders would, of course, appoint this board of directors of the corporation, which would in turn appoint the officers of the corporation, who would be the director general, the science, the research director, and all the other important officers of the corporation. And the actual work of the construction and operation would be largely carried out by the subcontractors. As I said in our assumption number 2, the existing institutions would then be the primary performers in actually creating and operating the facility in the long run. And that could be, of course, big labs, university collaborations, etc. So as I said, the board appoints a director general for a fixed term, say 5 years, perhaps renewable. The integration of the design, construction, and operation and administration of the Common Fund would be duties of this Director General, among other things. The majority of the work, as I've already mentioned, would be carried out by the subcontractors, constituted largely of units now participating in high-energy physics. There are, of course, other models, but this is one that seems to have the needed flexibility. In addition, the myriad details of how to solve the problems inherent in a very large collaborative venture have been well worked out and demonstrated in the business world, which operates with such a system. My dear friends and colleagues, we are facing the biggest challenge in the history of our field. Do we have the idea treasury to be successful in the end? Yes, we do. Do we have the enthusiasm that it's going to be required to carry us through to the end? You bet we do. Do we have the stamina to last the course in this great challenge? Yes, we do. Are we going to have to move mountains? Yes, we are going to have to move mountains. We must not shrink from that. Indeed, my friends, let it truly be said of us, in the days to come. Nec aspera torrent. They fear no difficulty. So be it.
So these were not the concluding remarks. And I think Jonathan Dorfin wants to have first some remarks now, and then Mike Witherell, and then we ask Peter Rosen afterwards, and then we open the panel discussion.